Good afternoon, ladies and gentlemen. Today I want to show you a little bit more about our new camera we developed. We call it the 3-in-1 matrix line scan camera. I will tell you how this camera works and where's the application for it. But first I want to introduce myself. So I'm Dirk Schoch. I'm working for the company Optronis since more than 20 years now. And let's talk a little bit about Optronis, just a short introduction. So the company exists more than 20 years. It's originally started very scientific based, so we built street cameras and classic high-speed cameras with integrated memory. But right from the start, when CoreExpress was invented, we developed cameras for CoreExpress interface, always targeting on high speed, high frame rate. Nowadays, we also support CoreExpress over fiber, which is the newest product line. But let's go to the product. So how was this idea born? What to do? Let's explain a 3-in-1 matrix line scan camera. So the idea was originally born together with our customer. So it's mentioned here. Oh, there's a picture missing. Yeah. So Synthecon came up to Optronis. It's a well-known customer from us. They looked for improvements of the current systems. So what they do right now, they do inspection machines to inspect vials with liquids or solid drugs inside. So that's their main purpose. And they used matrix cameras from us for their application. What they do is, so they have these vials in a rotating turret to inspect them. Right now, the speed they reach is about 600 units in a minute. And yeah, there's the way to improve things. That's an example on the right-hand side. That's an example of how a system looks right now. So it's called the oscillating drive unit. So I hope that works. Yeah, so now you can see the thing moving on the right side. There's the line scan camera, which is moving together with the containers. And this unit has to move back to the starting position. Second solution to make this kind of recording would be using an oscillating mirror. Then the mirror makes the movement instead of the camera. But both solutions are quite complex. You see the turret, that's a lot of mechanics. You have to spin each vial individually. So it's quite complex, costly. There are some drawbacks. And second drawback is when you do the movement of the camera, you make the recording. But when the camera has to go to the starting position, you have a kind of a dead time. So in that time, you cannot inspect. And that's roughly 15% of the time cannot be used. So now here the idea of the new camera comes into. So what are the basics here? On the left-hand side, that's our camera. That's a standard product. It's a matrix sensor. Works pretty much as every camera here in the market. You trigger it and it takes a picture. That's so far so easy. So what's new? The idea was to trigger each line individually and to move the line. So on the right-hand side, you see then, we call it it's a new matrix line scan camera. Now we send individually triggers to the camera. And each time there's a trigger, we jump to the next line and make an exposure of the next line. So first, line 1 exposure, then there's another exposure of line 2, line 3, and so on. So that's the basic idea of how doing that. To make it more clear, let's see how it works in the application. On the left-hand side, you see the circle with the green and gray colors. That's a symbol for the vials they are laying. and the whiles are rotating and moving to the right-hand side. At the same time, we trigger the camera and make the exposures. Let's show the sequence. So you see it's moving, and line 1, line 2, line 3, and so on are taken. So basically, the camera readout follows the while, or follows the upper surface of the while. And in the end, you get an assembled image. The main advantage here is, you saw the video before with the turret, with the whole mechanic moving. With that way, only the while is moving. The camera is fixed, so you have much less mechanics you need to realize this application. Let's see it in the real application, how it works. Maybe let's take one example on the upper left side. You see there's the while, it's the top end, and there's a cap on top. And there are some numbers and figures on it. So on the left-hand side, it's taken with a matrix mode. So it's all made with the same camera. So you can do a matrix mode, normal picture, or you switch to the MLS mode, and then you get an unwrapped image. So it looks like a normal, like a line scan image, you know. Maybe pick another example. Also left side down. That's also the while. You look inside. This time there's a powder inside. And you see if you only have the matrix image, it's very difficult to analyze and measure it because you have this distortion of the bending of the surface of the while. And on the right-hand side, you see the unwrapped image, which is easier to analyze and to look at. And this change between matrix mode and MLS mode, this line scan mode, that's just one parameter of the camera. So it's done in a millisecond. You can switch, depending on the application, you can switch matrix, multi-line scan mode very quickly, very fast. So what are the benefits for this camera in the application? So our customer Syntagon, so it's mainly their benefits they see. So first point, reduce mechanical complexity. That's the main thing, because you have this turret, which is large, which is complex, and you get nearly rid of such a system. It's already approved in application. So before I mentioned the inspection speed was 600 units in a minute. With the new camera system, they reached already 800 units. But in theory, the camera, with the speed of the camera, it's possible to go up to 2,000 units in a minute. So it's about a factor of 3 you can improve the application. I haven't talked about numbers already, but here you see the whole system, the scanning runs with 130 kilohertz. So that's pretty fast. And it's a line length of 2,500 pixels. During the application, we saw also another advantage, because you can swap quickly between matrix and MLS mode. It's much easier to set up such a camera in the environment or in the system, because in the area you see easily, okay, I'm targeting to this area. You can adjust focus, you can adjust the camera. That's much easier. And then you swap to MLS mode and you can start your recordings. I think when you install a line scan camera, it's much more complex to adjust it to the application. So here, that's another advantage here. So let's go. So what's the product look like? So that's the camera used for it. So basic parameters for this camera. Basically, it's a core express camera running with 4 channels, so it means 50 gigabit per second data rate. The sensor can do 5 megapixel with close to 700 frames per second. And so that's the basic, and that's also our standard product. And with the new MLS mode, we address the camera in a different way. So here we read out 2,560 pixels by one pixel. In the examples before, it was only showed to read out one line. and then jump. But in reality, this can be a little bit more complex. So we can also read out 2 lines or 4 lines at the same time with the same speed of 130 kilohertz. That gives you more space to adjust the camera to different applications. Also, it is possible to say you cannot read out 1 line just once. You can also say, okay, I read it 10 times. Maybe if you have a low light application, you can say you want to acquire more images at the same position. You can do that at the same thing. Another small advantage is once you run the camera in MLS mode, it's possible to switch to just 1 co-express channel, which saves some system costs because you can run 4 cameras at one 4-channel grabber. Makes it a little bit more cheaper in the total system costs. And now let's see, we have a demonstrator at our booth where you can see how the system works in real time. First, a small, how to explain what it is, what you see. On the right-hand side, you have the Vision PC. Then in the middle, the black part, which is, that's ramp. So that's used to accelerate the while. Then we have the 2 blue, the cables with 2 blue things on it. That's the speed sensor. So we have to measure the speed of the while, because depending on the speed of the while, you have to send the triggers to the camera. And then there's a light, and on top you see the camera with the lens. So let's feed the system. So first we run it in a matrix mode. So you see the while is running downwards, then you see a matrix image. So it's just a part of the while. Then the system is switched to MLS mode. Let's see what happens. Okay, now you see you have an unwrapped image of the while. That's the main thing what we are doing here. And that's all without any complex mechanics, because all the movement done is inside the camera. So the sensor is doing the movement, the line movement. So that's the core idea. And possible applications for this are especially things which are rotating and moving at the same time. Then we see a real advantage of such a system. We have the demonstrator at our booth. You are free to visit us and have a look at it. I would be happy to show it to you. And so I'm at the end of the presentation. Thanks a lot for your attention.
Okay, thank you very much. That was fast.
Yes, I see. There's some time left.
But there is a lot of room for questions. Are there any questions? Oh yeah, please.
Did you already have different applications than this?
Actually not, because that's brand new to develop together with our partner. But we can think about applications like in food industry or in a bottle industry, where also you have bottles moving or turning around. And here it's the same thing. You want to check the outside surface of the bottle. You want to see scratches or damages. But you also want to see maybe the inside of the liquid, if there's some, I don't know, a fly or something, some contamination. Yeah. Okay.
Okay, another question. You're welcome.
It is hardware trigger every single time the line is acquired, or?
Yes, exactly. So the camera works completely independent. Mm-hmm. So we program the camera in advance. So you say, okay, I'm awaiting 4,000 triggers, or I want 4,000 lines accumulated to one image. So that's pre-programmed. So like the PLC generates trigger points for the camera. Mm-hmm. So like I showed the speed sensor. So the speed is calculated, and depending on that, triggers are sent to the camera.
Mm-hmm. The application that you show is only black and white. Do you also provide it color cameras, or it's only black and white technology?
Actually, that's only for mono developed.
Uh-huh.
But it's a good question. I don't know, actually, if it's for color. It's more difficult because you have to calculate the colors and you need more pixels around. So with one line, it's, I would say, impossible, but with 4 lines, maybe there's a way, yeah.
Okay.
Okay. Are there? Okay.
Thank you. Just a question, is it a special sensor that you use, or is it the switching of the mode, is it on the camera or on the sensor?
That's actually the camera addressing the sensor. So we are using very special sensors. You saw the speed of 130 kilohertz, which is pretty fast. Most sensors are not able to do that with a small region of interest like that.
But you could also use any other sensor which is on the market?
Yeah,
okay.
in theory, yes. Yeah, it would be much slower, I guess. Not like with that speed. Yeah.
Thank you.
Okay.
Okay, thank you very much. Any further questions? If this is not the case, then thanks again.
Okay, thank you very much.
Thank you very much.